Building the future, one piece at a time. An introduction to prefabricated construction. Prefabricated construction, often shortened to prefab, is a modern approach to building. Instead of constructing everything on site, components are made in a factory setting. These pre-made parts, like walls, floors, or even entire rooms, are then transported to the building site. Once there, they are assembled like a giant puzzle. This off-site manufacturing process offers numerous advantages over traditional construction methods. Imagine a Lego set, but for buildings. That's the basic idea behind prefab. Just as you can assemble complex structures from Lego bricks, prefabricated components can be used to create a wide range of buildings from houses to hospitals. Prefabrication is rapidly gaining popularity as a faster, more efficient, and sustainable way to build. Prefab construction allows for greater precision and quality control. Since components are manufactured in a controlled factory environment, there's less risk of errors and inconsistencies. This results in higher quality buildings that are built to last. From single-family homes to large-scale commercial projects, prefab is transforming the way we build. A look back, from ancient origins to modern marvels. While prefab may seem like a recent innovation, its roots run deep into history. The concept of assembling parts off-site and then bringing them together for final construction is not new. In fact, it dates back thousands of years, showcasing the ingenuity and resourcefulness of ancient builders. Ancient civilizations utilized prefabricated techniques, albeit in simpler forms. These early methods laid the groundwork for the sophisticated processes we see today. From the Egyptians to the Greeks, many cultures experimented with modular construction, creating structures that were both functional and enduring. For instance, the Romans used precast concrete to construct arches and aqueducts, demonstrating early ingenuity in off-site construction. Their ability to create durable and complex structures with pre-made components was a testament to their engineering prowess and has influenced building techniques for centuries. The Industrial Revolution marked a turning point for prefabrication. With the advent of new machinery and the rise of factories, the production of building materials became more efficient and standardized. This era saw the birth of mass production, which revolutionized the construction industry. The invention of new machinery and mass production techniques paved the way for the factory production of building components. This shift not only sped up construction times, but also reduced costs, making buildings more accessible to the general population. One notable example is the Crystal Palace, built in London in 1851, which featured prefabricated cast iron and glass components. This iconic structure showcased the potential of prefabrication on a grand scale, inspiring future architects and engineers to explore new possibilities. The 20th century witnessed the rise of prefabricated housing as a solution to post-war housing shortages. With millions of people in need of homes, prefab offered a quick and efficient way to meet the demand. Governments and private companies alike turned to this method to rebuild communities and provide affordable housing. Companies like Sears and Lustron developed pre-designed homes that could be shipped directly to consumers. These homes came with all the necessary parts and instructions, allowing families to assemble their own houses with relative ease. This innovation not only provided shelter, but also empowered individuals to take part in the construction process. These early prefab homes offered affordability and convenience, shaping the future of residential construction. They demonstrated that quality housing could be produced quickly and cost-effectively, setting the stage for the modern prefab movement. Today, advancements in technology and design have propelled prefabrication to new heights. Modern prefab construction is characterized by precision, efficiency, and sustainability. Innovations in materials and techniques have expanded the possibilities, allowing for the creation of complex and aesthetically pleasing structures. Computer-aided design, or CAD, and building information modeling, or BIM, allow for greater precision and customization in the design and manufacturing of prefab components. These tools enable architects and builders to visualize and plan every detail, ensuring that each piece fits perfectly and functions as intended. From sleek modern homes to sustainable, energy-efficient buildings, prefab is pushing the boundaries of what's possible in construction. As we continue to innovate and refine these techniques, the future of prefabrication looks brighter than ever, promising to deliver even more impressive and sustainable solutions for the built environment. The prefab advantage: speed, savings, and sustainability. One of the most significant advantages of prefabricated construction is its speed. Traditional construction methods can be time-consuming, often delayed by weather conditions, labor shortages, and other unforeseen issues. Prefabrication, on the other hand, allows for simultaneous site preparation and building assembly, drastically reducing the overall timeline. Because components are manufactured off-site, construction can proceed much faster than traditional methods. This off-site manufacturing process is highly efficient, with specialized machinery and skilled laborers working in a controlled environment to ensure precision and quality. This reduced construction time translates to lower labor costs and faster occupancy for building owners. The quicker turnaround means that businesses can start operations sooner, and homeowners can move in faster, leading to significant financial benefits. Prefabrication also offers cost savings through efficient material usage and reduced waste. In traditional construction, material waste can be substantial, but prefab methods optimize the use of materials, cutting down on excess and ensuring that every piece is used effectively. Factory production minimizes material waste and allows for bulk purchasing of materials, resulting in significant cost reductions. Bulk purchasing not only lowers costs but also ensures a steady supply of materials, avoiding delays and keeping the project on schedule. Furthermore, the controlled factory environment protects materials from theft and weather damage, further minimizing waste. This protection ensures that materials remain in optimal condition, reducing the need for replacements and additional costs. Sustainability is another key benefit of prefab construction. The construction industry is a significant contributor to environmental degradation, but prefab methods offer a greener alternative. The use of recycled and sustainable materials, combined with reduced construction waste, makes prefab an environmentally friendly choice. By incorporating eco-friendly practices, prefab construction helps reduce the carbon footprint and promotes a more sustainable future. Additionally, the energy efficiency of prefab buildings can lead to lower operating costs and a reduced carbon footprint. Energy-efficient designs and materials ensure that buildings require less energy for heating, cooling, and lighting, resulting in long-term savings and environmental benefits. Prefabrication also offers improved safety for construction workers. Traditional construction sites can be hazardous, with risks of falls, equipment accidents, and exposure to harmful substances. With much of the construction taking place in a controlled factory setting, workers are exposed to fewer hazards and risks associated with traditional construction sites. The factory environment is designed to prioritize worker safety with strict protocols and advanced safety measures in place. This emphasis on safety contributes to a more efficient and productive work environment. When workers feel safe, they can focus better on their tasks, leading to higher quality work and faster project completion. Prefabrication not only revolutionizes the construction process, but also enhances the overall well-being of those involved. The prefab challenge: overcoming obstacles on the road to efficiency. While prefab construction offers numerous advantages, there are also challenges to consider. Prefabrication, or prefab, involves manufacturing building components off-site in a factory setting and then transporting them to the construction site for assembly. This method can significantly reduce construction time and improve quality control. However, it is not without its hurdles. One of the primary concerns is the initial investment cost. The upfront expenses for setting up a prefab manufacturing facility can be substantial. This includes the cost of purchasing or leasing land, constructing the factory, and investing in specialized machinery and technology. Additionally, there are costs associated with training the workforce to operate these new systems efficiently. Setting up a prefab manufacturing facility requires significant upfront capital expenditure. This investment is necessary to ensure that the factory can produce high-quality components that meet the required standards. The factory must be equipped with advanced machinery and technology to handle the precision and scale of prefab production. Moreover, maintaining a skilled workforce is crucial for the success of the operation. However, this cost can be offset by long-term savings in labor and materials. Prefab construction can lead to more efficient use of resources, reducing waste, and lowering overall material costs. The controlled environment of a factory allows for better quality control and minimizes the risk of errors and rework. Additionally, the speed of construction can result in significant labor savings, as projects can be completed faster than traditional methods. Transportation of large prefab components can be another hurdle. The logistics of moving these sizable and often heavy components from the factory to the construction site can be complex and costly. This process requires careful planning and coordination to ensure that the components arrive on time and in good condition. Any delays or damage during transportation can lead to increased costs and project delays. The size and weight of these components may require specialized transportation and logistics, which can add to the overall project cost. Specialized trucks and equipment are often needed to handle the transportation of prefab sections. Additionally, permits and route planning are essential to navigate any regulatory or logistical challenges that may arise during transport. Careful planning and coordination with transportation providers are essential to ensure smooth delivery and minimize potential delays. This involves working closely with logistics experts to develop efficient transportation plans and contingency strategies. Effective communication and collaboration among all parties involved are key to overcoming these logistical challenges and ensuring the timely delivery of prefab components. Integration with existing building codes and regulations can also pose challenges. Prefab construction must comply with the same building codes and regulations as traditional construction methods. This can be complicated by the fact that building codes vary significantly across different regions and jurisdictions. Ensuring that prefab components meet all local requirements is essential to avoid legal and regulatory issues. Building codes vary across regions, and prefab construction must comply with local requirements. This means that architects and engineers must be well versed in the specific codes and regulations of the area where the project is being built. They must adapt the design and construction plans to meet these requirements, which can add complexity and time to the project. Working closely with architects, engineers, and regulatory bodies is crucial to ensure compliance and avoid potential roadblocks. Collaboration and communication among all stakeholders are essential to navigate the regulatory landscape successfully. By involving regulatory bodies early in the planning process, potential issues can be identified and addressed before they become major obstacles. Despite these challenges, the benefits of prefabrication are increasingly outweighing the drawbacks. Prefab construction offers numerous advantages, including faster build times, improved quality control, and reduced environmental impact. As the construction industry continues to evolve, the adoption of prefab methods is expected to grow, driven by the need for more efficient and sustainable building practices. As technology advances and the demand for faster, more sustainable construction methods grows, prefab is poised to revolutionize the construction industry. Innovations in materials, manufacturing processes, and construction techniques are making prefab more accessible and cost-effective. The integration of digital tools and automation is further enhancing the efficiency and precision of prefab construction. The future of building is prefab, offering a path towards greater efficiency, sustainability, and innovation in the built environment. As the industry continues to embrace these advancements, prefab construction is set to play a pivotal role in shaping the future of how we build, creating structures that are not only faster and cheaper to construct, but also more environmentally friendly and resilient.